Okay, today we're going to be talking about functions. So let's remind ourselves kind of what a function is. And since we're going to be talking about function equations, it's helpful to think about functions like you think about a machine. A machine takes things in and then it puts things out that are different, and something is going on inside of this machine to give us something different on the other side. So in math, usually we call what's going into the machine an input and what's coming out the other side an output. So let's look at an example. So let's evaluate with the function rule f of x equals 2x. And in this case, when I say rule, that's what our machine is doing here. Our machine is doing 2 times x. So when we put x values into the machine, when they come out the other side, they're going to be doubled because that is the rule of our function. So let's look at a couple examples. Let's say I want to input 3 into this function machine. So if I input 3, we write it like this to show the input. My 3 is going to go into my machine. The rule is going to be performed, so 2 times 3, and out the other side, I'm going to get 6. Okay, let's try another number. How about 7? Okay, let's look at what's going to happen to 7 when it goes inside my machine. So I'm inputting 7, and the rule here is that it's going to be doubled, and when it comes out the other side, it will be 14. And let's do one more. How about -1? So I'm going to input -1 into my machine, and I'm going to perform the rule. And on the other side, I'm going to get -2. So this is a really simple rule, but keep that visual of a machine when we get to our next slide where, it's a little more complicated. So here we have the function rule -5x plus 4. And one thing I want you to notice about this function rule is it looks a lot like the equation of the line. In fact, it is an equation of the line. So y equals mx plus b. But instead of y, when we're talking about functions, we call it f of x. Okay, so now my machine has a little more complicated of a rule, but the same theory applies. We're going to put something in, the rule is going to be performed on it, and then something's going to come out the other side. So let's start with a simple number. How about 1? Let's start with 1. So we're going to input 1 into our machine here. So I'm going to put the number 1 in, and I'm going to write my work off to the side here. When I put 1 in, I have to do -5 times 1 plus 4, because that's the rule of this machine, which is going to give me -5 plus 4, which is equal to -1. Okay, so a little more work involved for this rule. Let's try another value. So we put -1 into our machine, and our output was -1. Let's try another value. How about 2? Let's input 2 into our machine. -5 times 2 plus 4. -5 times 2 is -10 plus 4 is going to be equal to -6. And let's do one more input. -5 times 3 plus 4. It's going to give me -15 plus 4 equals -11. So in this case, the function rule is causing our outputs to be negative. Okay, so let's look at some application of what we just did. So, keep that picture in your mind of the machine. In this case, we have a function 7x plus 5, and this represents how much bowling will cost after X number of games. And then it says evaluate the function for f of 4. So what we're saying is, how much will this cost after 4 games? That's what evaluate for f of 4 means. So what we're going to do is we're going to write f of 4. This is our input. The rule is 7x plus 5. So I'm going to input 4 here. F of 4 equals 7 times 4 plus 5. And f of 4 is going to be equal to 28 plus 5, which means after 4 games of bowling, it will cost $33. Let's look at another example. So here is a nonlinear example. We've been looking at linear examples. Evaluate f of x for f of 3. Okay, so we're going to put our input here. F of 3 is equal to 3 squared. So we're just replacing x with our input, performing our rule. 3 squared is 9 minus 2 equals 7. And the way we might state our answer is f of 3 is equal to 7. And when we say this, what we're saying is when we input 3 into our function machine, it's going to output 7.